Demonstration of our MPPT goes like this. This is our LCD where we have total power that we are extracting from the panel. Right now we have this load of 35 watts directly on the panel without MPPT. We are able to extract about 3 watts. Now switching to MPPT. Our system is tracking the maximum power point. And it will settle around the maximum point. That is 16 watts. Hi friends, I am Jayaditya. Now I'll explain you each component of the MPPT circuit. Here we have the MSC430G2553, which acts as a brain behind whole algorithm. Here on the LCD we have current monitoring, which is right now 1.13 amperes, voltage about 11.82 volts, duty cycle of our PWM is 9%, and wattage we are extracting is 1.6 watts. Now MSC430 gives the commands to DAC, which is a 16-bit DAC from Texas Instruments, and it provides the analog signal for PWM generator TL494, which is right now working at 60 kHz frequency. This TL494 is a PWM generator with 2 error amplifiers. One error amplifier is biased so that it produces no effect on the PWM, and other is getting the feedback from the DAC, which in results gets the voltage from MSC430. Here in the sensing and control circuit we have a shunt resistor about 0.001 ohms. This is a current monitor. Here we have another package for the current monitor, which is INA212 with a configurable gain about 1000 dB. Now here we have the voltage divider to sense the input voltage. This is the MOSFET driver, which is used to drive the MOSFET in the DC-DC converter, that we'll talk about later. Now as the circuit moves forward, the PWM signal increases, and this MSC430 reads the inputs and then finds the maximum power point. In DC-DC converter we have switching devices, IRFZ44, body diode, which is one of the basic component of a DC-DC converter, an inductor, input capacitor and output capacitor. Here I'll talk something about the algorithm that we have used in our MPPT control system. Here we have the algorithm incremental conductance, which is one of the famous and hardest to realize algorithm. We calculate delta V, delta I and delta P in the first step. Delta V equal to 0, that means the previous sample is at the same level as the current sample and there is no change in operating voltage of the panel. Then it goes for checking the condition for delta I. Delta I changes as soon as the load changes. So this whole circuit is very much controlled by a load. Now if the delta I is less than 0, then it will go to this condition and increase the operating voltage of the panel. Then the loop will return and the whole process continues again. If the irradiance of the solar panel changes, we'll have delta P upon delta V not equal to 0, and accordingly the PWM changes. For settling the PWM, we have introduced a PID loop, which works on exact method like proportional, differential and integrational circuit. So our system can track any change in load or the irradiance very fast, and it can track the MPPT in few milliseconds.